What's up everyone? It's Stack Lessons here. Welcome back to the channel. Today we're diving into Checkpoint 2, Agent Framework Decisions in Practice. Let's get into it. A team at a Fortune 500 retailer rewrote a working LangChain agent from scratch because someone in a review said it wasn't native enough. They shipped 2 weeks late, and the rewrite behaved identically. That call, and 4 others like it, is what this video is about. By the end, you'll be able to look at any agent build requirement and name the right brick, the right framework layer, the right registration flow, the right serving mode, and the right MCP host in under a minute. Quick grounding before we start. Across the last few episodes, you built 2 agents end-to-end through Agent Bricks, the Mosaic AI agent framework, PyFunk registration in Unity Catalog, and MCP tool servers. You also picked up the retrieval quality knobs, hybrid search, re-ranking, and the instructed retriever. All of that experience now becomes a decision-making muscle. Here's the move underneath every decision in this video. The senior engineer doesn't memorize a catalog of services. They look at the requirement, find the one constraint that actually decides it, and let that constraint eliminate everything else. That's the habit we're building today, 5 times in a row. Here's the map. First, which agent brick fits the use case? Second, chains versus the agent framework, author or deploy. Third, the PyFunk and Unity Catalog registration flow. Fourth, the serving mode, pay per token or provisioned throughput. And fifth, the MCP server type, managed, external, or custom. Each one is a service boundary. Pick the wrong side, and everything downstream gets harder. Scenario 1. Databricks procurement team just landed a new pipeline. 40,000 supplier PDFs, every vendor formatting them differently. They want product, price, and SKU pulled into a Delta table whenever a new PDF lands. There's no chatbot in this picture. No conversation, just unstructured documents in, structured rows out. Which agent brick fits? Pause for a second before the next slide. Here's the constraint that decides it. The shape of the input is unstructured documents, and the shape of the output is structured rows in a table. It runs on arrival, as a pipeline, not in a conversation. That sentence alone eliminates 2 of the 3 bricks. On the wrong side, Knowledge Assistant is built for chat with citations, not batch rows into a table. Multi-agent Supervisor routes a conversation between specialists. It isn't a parser, and hand-rolling RAG here pays you nothing. You'd be reinventing a brick that already exists. On the right side, information extraction, schema-guided, built on the AI extract SQL function, and it deploys as a LakeFlow pipeline that picks up new documents on arrival. It's exactly the shape Databricks used in episode 5 for the excavation reports. So the rule for the brick family. If the scenario says pull fields from documents into rows, that's information extraction. If it says chat over our documents with citations, that's Knowledge Assistant. And if it says route between SQL, docs, and tools depending on intent, that's the multi-agent Supervisor. Match the verb to the brick before you think about anything else. Scenario 2. A team has a working chain, written with Databricks LangChain, composed with LCEL, tested in a notebook. Leadership wants it in production with tracing, governance, and a real serving endpoint. In the design review, someone proposes throwing the whole thing out and rewriting against what they call a native agent framework SDK. Is that actually the call here? Here's the constraint people miss. The Databricks LangChain package and the Mosaic AI agent framework aren't competitors, they're different layers. One is how you author the logic, the other is how you ship it. They stack on top of each other, and you don't have to pick. On the authoring side, Databricks LangChain with LCEL is fine. So is LangGraph, or Llama Index, or plain Python. The agent framework doesn't care. On the deployment side, You wrap whatever you authored as a responses agent, log it with MLflow, register it in Unity Catalog, and serve it through model serving, tracing, evaluation, and governance ride along for free. The existing LCEL chain doesn't get rewritten, it gets wrapped. So the rule: keep the chain you already have, wrap it as a responses agent. The agent framework is a wrapper around your authoring choice, not a replacement for it. Any answer that involves throwing out working LangChain code to adopt a Databricks-only SDK is the wrong call. Scenario 3. Datadino's fossil chatbot is ready to register. 4 candidate code snippets land in the pull request, and only one of them is correct under Unity Catalog. The interesting question isn't which one is right, it's what makes the other 3 wrong. Unity Catalog insists on 3 things: a 3-level name, catalog, schema, and model, a model signature on every version, and aliases instead of the old none, staging, production stages. Miss any one of those, and the snippet is wrong. Straight from the Databricks docs on model lifecycle. Stages are not supported for models in Unity Catalog. The recommended pattern is the 3-level namespace for environment and aliases for promotion. Keep that line in mind as we walk the options. 4 things disqualify a snippet on site: a 2-level name like fossilrag.chatbot, missing the catalog, a missing call to MLflow.set registry URI pointing at Databricks UC, a log model call with no signature or input example, and anything calling transition model version stage. The correct flow has all 4 moves. Set the registry URI to Databricks UC, log the PyFunc model with a signature and an input example, register under the full 3-level name like prod.fossilrag.fossilchatbot, and promote with set registered model alias pointing at champion. So the rule: 3-level name, model signature, promotion by alias. If any of those 3 are missing from a snippet, it's the distractor. The full canonical line for Datadino is prod.fossilrag.fossilchatbot, with a champion alias pointing at the version that's currently serving. Scenario 4. A customer-facing agent is launching next week with a hard latency SLA in the contract. It runs on a fine-tuned 8 billion parameter model, not a stock foundation model API endpoint. Traffic is sustained throughout the day, not bursty, and the workload is HIPAA scoped, pay per token, or provisioned throughput. 3 words in the brief decide this: SLA fine-tuned. HIPAA, any one of them, on its own, forces dedicated capacity. This scenario has all 3 at once, which makes it an easy call once you spot the cues. From the Databricks Foundation Model API docs, pay per token is the easiest way to start accessing foundation models on Databricks. Provisioned throughput is recommended for all production workloads, especially those that require high throughput, performance guarantees, fine-tuned models, or have additional security requirements. That sentence is the rule, almost word for word. Pay per token fits prototypes and internal demos, low-volume bursty traffic, stock foundation model endpoints, and workloads with no SLA or compliance profile attached. Provisioned throughput is the answer when there's a production SLA on latency, a fine-tuned or bring-your-own model, AHIPAA scoped workload, or sustained predictable load. This scenario hits the right column on every row. So provisioned throughput, with capacity sized to peak demand. So the rule: if you see SLA, fine-tuned, or HIPAA anywhere in the brief, pick provisioned throughput. For anything else, prototypes, demos, bursty internal tools, start on pay per token and graduate when the workload graduates. The hourly bill is the cost of predictability. Scenario 5. An agent needs 3 tools: a Genie space over portfolio data, a GitHub pull request lookup, where each user should see only their own pull requests, and an internal billing API that lives in a private VPC3 tools, 3 different hosts, managed, external, or custom for each one? The constraint that decides this is just one scenario. Where does the tool actually live? If it lives inside Databricks already, managed MCP. If it's a public software as a service tool with its own MCP server, external. If it's your own private API with nothing off the shelf, custom. Ask that question once per tool. Tool 1. The Genie space. It lives in Databricks already, governed by Unity Catalog. That's managed MCP, with on behalf of user auth, so row-level security applies automatically. Tool 2. GitHub pull requests. GitHub is a public software as a service tool, and there's an off-the-shelf MCP server for it. That's external MCP, proxied through AI Gateway, with per-user OAuth so each user sees their own pull requests. Tool 3. The internal billing API. Nothing off-the-shelf exists for that. That's custom MCP, hosted as a Databricks app with the MCP prefix and the can-use permission grant on the app itself. So the rule: don't build what Databricks already ships. Check the managed list first: vector search, Genie, Unity Catalog functions, Databricks SQL. If it's a public software as a service tool, look for an external MCP server before writing any code. Custom is the last resort, reserved for genuinely private APIs with no off-the-shelf option. Notice what every one of those 5 decisions actually was. Each one came down to the same question: where does the boundary sit? Between unstructured input and structured output, between your code and Databricks infrastructure, between dev, staging, and prod, between your workload and the model provider, between the agent and its tools. Get the boundary question right before you write a line of code, and the framework choice falls out of it. That team that rewrote their LangChain agent, they never asked where the boundary sat, and that's exactly why they shipped 2 weeks late on a rewrite that changed nothing. You can now ship an agent. The harder question is whether it's safe to ship, and that's what the next block of episodes is about. Guardrails come first, the controls that decide what the agent is allowed to say and do, then evaluation, scorers, LLM judges, and MLflow traces, for catching quality drift before your users do. Same data Dino. Harder questions. Alright, let's test what you've learned. Question 1. A logistics company has 25,000 customs declaration PDFs arriving monthly, each from a different broker with no consistent template. They need shipment ID, declared value, origin country, and HS code pulled into a Delta table as soon as each PDF lands. No chatbot is needed. Which Databricks option fits the requirement? A. Knowledge Assistant brick over the PDFs with citations. B. A hand-rolled RAG agent with a custom PyFunc parser per broker. C. Information extraction brick deployed as a Lakeflow Spark declarative pipeline. Or D. Multi-agent supervisor routing between Knowledge Assistant and a Unity Catalog function. Take a moment to think about it. The answer is C. The shape of the problem is unstructured documents in, structured rows out, on a pipeline, and that's exactly what information extraction is built for. Deploying it as a Lakeflow pipeline means new declarations get processed on arrival, no per-broker code required. Knowledge Assistant and Supervisor are conversational tools, and rolling a custom parser per broker is the work this brick exists to avoid. Question 2. A team has a working LCEL chain built with Databricks LangChain. Leadership now wants the chain deployed with MLflow tracing, Unity Catalog governance, and a model-serving endpoint behind an SLA. A junior engineer proposes rewriting the chain against a, quote, native Databricks agent framework SDK before deploying. Which response is correct? A. Keep the chain and wrap it as a responses agent, then log, register, and serve through the agent framework. B. Rewrite the chain. Databricks LangChain is not supported by Mosaic AI deployment. C. Pickle the chain and upload to S3, then expose it through a hand-rolled Flask service. Or D. Replace LangChain entirely with raw OpenAI API calls before logging the model. Take a moment to think about it. The answer is A. The Databricks LangChain package is the authoring layer, and the Mosaic AI agent framework is the deployment layer. They stack, not compete. Wrap the existing chain as a responses agent, log it with MLflow, register it in Unity Catalog, and serve it. Pickling and uploading to S3 is exactly the pattern that crashed Datadino's first deployment in episode 12. Question 3. An engineer is registering a PyFunc agent in Unity Catalog and promoting it to production. Which sequence of MLflow calls is correct? A. Log model, then register model with the name fossilrag.chatbot, then transition model version stage to production. B. Set registry URI to Databricks UC, log model with a signature and input example, register model under prod.fossilrag.fossilchatbot, then set registered model alias to champion. C. Set registry URI to Databricks, log model, then transition model version stage to production. Or D. Log model only, Unity Catalog registers and promotes automatically. Take a moment to think about it. The answer is B. Unity Catalog requires the registry URI pointed at Databricks UC, a three-level name like prod.fossilrag.fossilchatbot, and a signature on every version. Stages aren't supported in UC. Promotion happens through aliases like champion. Options A and C use a two-level name and stage transitions, both disqualifying, and D skips registration entirely. Question 4. A healthcare agent is launching to handle 50 queries per second sustained throughout the business day. It runs on a fine-tuned Llama 3.370 billion parameter model, must meet a 1.5 second P95 latency SLA, and is HIPAA scoped. Which model serving mode fits? A. Pay-per-token foundation model AP is cheapest option, will autoscale. B. AI functions via AI query, runs inference in parallel for high throughput. C. External models, proxy traffic to OpenAI for better latency. Or D. Provisioned throughput foundation model AP is dedicated capacity size to peak demand. Take a moment to think about it. The answer is D. All three triggers are present: an SLA on latency, a fine-tuned model, and HIPAA scope. Any one of them on its own would force provisioned throughput. Pay-per-token shares capacity and doesn't host fine-tuned models or compliance profiles. AI functions is for batch scoring over delta tables, and external models routes to third-party providers. Neither matches a HIPAA scoped fine-tuned workload. Question 5. Let's test a concept from an earlier episode. A team building an agent needs 3 tools. 1. Query a Genie space over sales tables. 2. Look up each end user's own Jira tickets. 3. Call an internal pricing service that lives behind a corporate VPN with no public MCP server. Which MCP server types should they use? In order: A. Managed for Genie, external with per-user OAuth for Jira, custom for the pricing service. B. Custom for all 3, gives the most control. C. External for Genie, managed for Jira, external for the pricing service. Or D. Managed for all 3, Databricks hosts everything by default. Take a moment to think about it. The answer is A. The decision is driven by where each tool actually lives. Genie space is stored inside Databricks, so managed MCP applies with Unity Catalog permissions and on behalf of user auth. Jira is a public software as a service tool with its own MCP server, and per user OAuth scopes each call to that user's own tickets, that's external. The internal pricing service has nothing off the shelf and lives in a private network, so custom MCP hosted as a Databricks app is the last resort fit. And that's a wrap on Checkpoint 2, Agent Framework Decisions in Practice. If this helped, subscribe for the rest of the Databricks GenAI Engineer Cert series. It helps me keep making these lessons free, and I'll see you in the next one.